Okay, that should be done. Oh, hi, fellow viewer. Welcome to our channel, to Zeta Theta Maths. Hope you're doing well. So we've gone through some few things, of course. We've done a partial fractions video very recently. We've done part 1, we'll be doing a part 2 soon. We've done a binomial expansion video, which I think it was an hour long. I know your attention span isn't that great, but it's okay. It's completely fine. You can watch that some other day. And we've done a third video. I mean, that's actually our first one, but it was about, of course, projectile motion and how a gun works. You guys really enjoyed that. So what would you like me to do? And comment anything down below that you would like to see me do in the future.
Oh Philip, me and Zane have watched this at least 50 times and it was never let us down. The England language is woefully insufficient when describing this mind-bending content. Can you please make a video on Zane form NSB 6 form, as he really wants to commit the haram with you, smiley face, and smell your meat.
Wow, Charlie, thank you for all the support, thank you for all the help, and thank you for complimenting me. However, if you're talking about any smelling of meat, it's not my meat, it's my dad's. He's cooking a very nice steak downstairs. You can go try it any day. However, I've got to go and answer another comment. Okay, thank you for your question. How about you over there? Yeah, you. Could you maybe let me know what I should do next? Yeah, thank you. He's just referring to my dad's cooking skills. Yeah, thanks a lot. Okay, go on with the question.
OMG, this is so good. Me and my friends love you. You are so cute. And by the way, just so you know, Charlie wants you.
Well, hi. I hope you're okay as well. Yeah. Unfortunately, I do know he wants to smell my meat, but I keep telling him it's not my meat, it's my dad's. He's the one who's got the cooking skills. I keep repeating that to him over and over again, and he still won't listen. I mean, answering these questions. Hello everyone to another video in Zeta and Theta Maths, and today we will be doing some partial fractions part 2. But just before we begin, I'd like to thank the following people for supporting me and making funny comments. So number 1 funny comment was from @CharlieCullymore, and I forgot his last number, but his sort of username and comment will appear on the screen. I think he had the funniest comment so far. The next one goes to @Sanzi6054. He had another funny comment, should again appear here. And an honourable mention is @LimeJuice8312. He just writes yes, and sometimes he puts an exclamation mark on the end. I don't know who he is, but I'd like to thank all of them for being very kind and hopefully very devoted and loyal subscribers to this channel. However, I wish I could go on, but we've got to start the video. So, another part in partial fractions that we will be going through after we left off is something that consists of a cubic on the bottom. So just here, when I mean cubic is when you multiply this, this and this all together, you get something that has an x cubed term and some coefficient at the front. So that's everything that I mean by cubic. However, in this case, it doesn't have a linear term at the top, it just has a 4 at the top and nothing else. So the top part should be easy, it's just this that we have to be sorting out. So before we begin, we have to do the following. So the very common rule that you always do in partial fractions is draw your line, and then given that because we don't have something that is greater than a cubic at the bottom, so say there was a quartic, you'd have to do something known as dividing fractions, so dividing polynomials essentially, but we don't have to do that for now because this is not greater than that. Anything that has a higher power at the top would have to be divided, but because we're given a cubic on the bottom and something very simple on the top, we don't have to do anything. So just so we can get started, again we draw a line because we're doing partial fractions, and in this case, because I like my ABCs, I'm just going to put A at the top like so. Now we can pick any of these, doesn't matter which order. In this case I'm going to just pick x plus 2 to be at the bottom. That's all we have to do, just add an x plus 2 at the bottom. There's really no mistakes when you're sort of looking for your structures in partial fractions. So let's do this like so. Now again we can pick another one, but first you have to do b. So you have to add on a b term. So again, draw your little line and then add on your b at the top like so. Now again we can pick any of these that are left. Let's put 2x minus 1 because that's what we're looking for. So 2x minus 1. Sorry if my handwriting is looking a little dodgy. I'm doing this all using a computer mouse, so it's a little, let's just say, shady. So then again, we can choose to do the same thing, but remember last time how we just did A and B, and that's all. Well, because we have that third term, as we said, because it's a this is a cubic, we're going to have to add on that C term on the end, with C being on the top and this being on the bottom. So now the last thing we have to do for forming our sort of equation for a partial fraction is to go like this. Put your C on the top and whatever here was at the bottom, so in this case x minus 3, that's what we add at the bottom like so.
Oh my god, bro. Hell no.
Now that we've got our 3 sort of partial fractions all nice and ready, the next thing we have to do is cross multiply like we did before. So in this case what we're going to have to do is we have to simply match the denominators, so that way the denominators here and on all of these fractions on the right side are the same as the denominators all here on the left side. And then we're going to copy and paste this and extend it out all nicely. Now I'm doing this because I'm using a computer. You can do this automatically when you're writing on your pen and paper, so that way you're not wasting space and so everything looks nice and neat. So I'm going to make this x plus 2 very tiny because the next thing we're going to do is going to require some space. So now that we have some space for the letters that are going to come in, or let's actually say linear expressions, is, well, if you want this to be the same as that, well, what is x plus 2 missing? Your x plus 2 is missing a 2x minus 1 and an x minus 3. So the first thing you want to do is multiply the top and bottom by 2x minus 1 and x minus 3. Okay, so now you've got your a term all nice and ready. The next thing you want to do is finish up with the b term as well. So let's just put a plus symbol, and now again let's just copy and paste our b term. Okay, now let's extend it all nice, so it's all nice and wide, ready for me to do our stuff. And now let's make this also a little smaller than it should be, so that way we just have that bit of space to work with. And again, as I said before, I encourage you, whenever you're doing this, leave yourself some space on the side, so that way you aren't always struggling and your examiners aren't struggling to read your handwriting. Anyway, given that we have our b and our 2x minus 1, well, again we have to look at what 2x minus 1 is missing at this side, so that way we can match up these denominators here. So this has 2x minus 1, this is x plus 2 and x minus 3. So just like before, we will just add on x add 2 onto here and x minus 3 onto there as well. Okay, so once you've done this, well, the whole point is again to have these matching, have these matching, and have these matching. But wait, we forgot another term. we also need C to get sorted out, just up here. So again, I'm going to copy and paste this very quickly. Okay, so now that we've got it in this form, now what we have to do is look for what is missing again. So this is not missing, but that and that is. So what we're going to do is again write these back down over again. Okay, so that is our C all nicely finished up. So just like before, being the fellow viewer you are, you may ask,
well, zeta theta maths, what do we do here? What shall we do? This is a big problem.
well, if you've noticed the trend, the whole point of doing this is so that way we can then cancel. I guess again, just like before, we get to evict these three terms out. So that way we can finally work out our A, B and C. So again, let's just cross these out. Boom, evicted, evicted. Now let's excommunicate. And now let's destroy these. And now I can't think of any words to destroy these, but let's just incinerate. So I'm going to rewrite this, I'm going to click and we'll be back. Okay, so we're back. So I've sorted this all out nice and neatly. So now all we have to do is, well, you're going to ask, actually, you are going to ask,
well, zeta theta maths, what do we do now to sort these little numbers out so we can find out what A, B and C is? After all, there are three terms, so what are we going to do?
well, we have to think of what X can be. So what can we think of X to be? Well, given that we know what we did last time, well, for simplicity reasons, let's start with the most simplest way to sort of cancel any term. So now, if I look at this term right over here, we know that we're going to have to put in a 3 here for this to be 0 and for this to all cancel out. So I'm going to allow this to equal 3 for now. So basically what happens is, because we've allowed this to become 3, this part right over here is now going to equal 0. So let me write that 0 properly again. So this part is going to die, that part's going to die, this A is going to die. They all have gone to heaven, unfortunately. So because this is going to be 0, what's going to happen is that this part's going to die, this part's going to die, this part's gonna die. So I really shouldn't use that term commonly in maths. So might end up using it in real life when interacting with other friends. But the whole point is that, oh look, we've now left with just one term, so we can solve this very easily. So given that this was 3, this is going to be of course 5. And because this was 3, this is going to be 6. 6 minus 1, that's 5. And because 5 times 5 is 25, what we're going to be left with on this side is 25c. So see what I mean? No, I'm joking. I'm not going to do that ever again. But because we've let that x equal to 3, what we're going to do is we're going to plonk it onto our side over here, just so that we know what we did before. But because our x equaled 3, now all we're left with is just a very simple 4, if this thing will let me write something. Okay, 4 is equal to 25c. Now, given that 4 is equal to 25c, well, what is 4 divided by 25? Is just 4 divided by 25. So again, let's just cancel this through, and that will just, this will of course imply that your C term is equal to 4 over 25. Now that was quite straightforward, because, well, we put in the 3 here, that was 6 minus 1. Now, well, 4 over 25 interestingly is actually equal to 0.16, and the reason why I'm saying this is because it's an exact number. It can be expressed in a few digits in a decimal, and it can be simply expressed as a fraction, so this is probably going to be correct. I mean, of course, if you have any objections, fellow viewers, then you can of course always put a comment down below.
Zeta theta maths, you got this incorrectly today, you should have done this.
Okay, listen, I claim that I'm correct because I got my A in maths, so I think that's a valid statement. So I'll be back in a minute after I clear this up very quickly in a flick of a switch. Okay, that was cleaned up very quickly. So now that we know that our C was 4 over 25, the next thing we're going to have to do is of course find our other terms. So we know our C, that was fine. now we're going to find out what our other terms were. So what can we allow x to equal? So we can also allow x to equal, well, let's look at 2x minus 1. So based on just looking at this, I can say x can equal a half. You may be asking, let me explain. So the reason why a half is because if we want 2x minus 1, so let me just, come on. Okay, if we want it to equal 0, then we're going to have to add on 1 to the other side, and then we're going to have to divide by 2. So we're going to have to do divide by 2, and then that's going to equal x. So then x equals a half, and this, because x will equal half, that will just give you 0. So if we clean this up very quickly, because we're allowing x to just equal a half, what we're going to do is put this to the side for now. This is just a reminder in case we get lost, and that's what I encourage you to do. Write something on the side so that way you don't get lost. So very similarly like before, this is going to actually cancel because that's going to equal 0. This is going to cancel, that's going to cancel. This is actually going to stay, so we're good with this. That's going to be fine. However, this is going to all just unfortunately die. So given that this is not going to cancel, well, what's a half plus 2? We know a half plus 1 is equal to 3 over 2. Add another 1, that will be 5 over 2. So this is going to equal 5 over 2, and I strongly encourage give labels like I'm doing right now, so that way you don't forget. I'm a very forgetful person in maths, so I prefer to add labels. Now similarly, what's a half minus 1? Half minus 1 is minus a half. Minus a half minus 1 is minus 3 over 2. Minus 3 over 2 minus 1, that's going to be minus 5 over 2. Now if you're not very strong with fractions or subtracting fractions, then what I strongly suggest is to very quickly check on your calculator if you're correct. So this is not going to of course exist, this is not of course not going to exist, and I encourage you to look around again. Sometimes you might be overlooking something. So okay, we've got that and that. Well, what happens when we basically square it with a minus outside? So 25 times 5 is 25. Let's just put a little 25 down here, and what's 2 times 2 is 4. Oh dear, okay, this is not looking too good. 25 over 4, but let's not forget our negative sign. We can't forget our negative, because if we do, then well, we're in a bit of trouble. So negative 25 over 4, and of course that's multiplied by b. So let's rewrite this expression down. So our new expression is now 4 is equal to negative 25 over 4, and it's going to be multiplied by b. So how do we solve this? Well, first off, multiply both sides by 4. Now because we've multiplied this side by 4, that 4 will cancel. So 4 times 4, 16. Okay, getting square numbers here. 16 is equal to minus 25 over b. 25b, sorry, multiplied by b. And you want to transfer this negative onto the other side. So let's make this plus. That's going to be a minus. Now divide. So then you end up getting 16 over 25 is equal to b. Now can this be simplified any further? Nope, it cannot. So 16 over 25b it is. So now let's find a, but let me just clear this up all very quickly in a flick of a light bulb. Okay, so we're back. So that was cleared up very quickly, but again we can store that value somewhere else like we've done here and here. Now we know that c is 4 over 25, b is 16 over 25. Now we're looking for a, so we're going to have to allow x to equal a digit that we haven't allowed to equal before, and that only thing that we haven't allowed to equal before is x plus 2. And because it's plus 2, we're going to of course have to put a negative here to give you a 0. And the nice thing about that is it will cancel this and this. So what that means is you'll only be left with a if you put a negative 2. So if we allow x to equal a negative 2, well, let's just put this to the side for a moment because I know what I'm doing. I'm just giving you examples so that you know what you're doing. So now that x equals negative 2, well, we do know is that we can very easily just poker these guys out. So goodbye b, goodbye you, goodbye you. Have fun in heaven, have fun in heaven, have fun in heaven. So now the only thing we're left to play about with is this. So again, let's be mathematicians, go around this very logically. Another way for logically is lazily, but never mind, it's okay, we're allowed to be lazy. But if you do it nicely and very logically, as in quote unquote, then well, that's what us mathematicians do. So negative 2 times negative 2 is negative 4, negative 4, negative 1, negative 5. So that's going to be negative 5. Now negative 2 minus 3, so that's negative 2, negative 3, negative 5. We have a very similar situation to what we had before, I think, with our b. So -5, -5. Well, multiply these together. Well, what do you get? Just 25. Two negatives make a positive. Now, that's going to just equal 4. So 25a is going to equal 4. So let's just solve this right here. Let's write our new algebraic expression. 4 is equal to 25a. Now, divide both sides by 25, and I guess a is equal to 25 is your final answer. So that's our second example done. So what I'm going to do is going to put this again to its side where it belongs. So I'm going to put a is equal to, because usually, well, examiners like it when you sort of make things very easy to read, because if you put the integer first or a number or whatever, then your a or letter, then they won't be asked to read that. So I'm going to put this all the way to its side where it belongs with her friends down here. Oh, and by the way, numbers do have genders. Anyway, here it is. So again, the whole key point about doing this is it's going to be a little bit more complicated than before, because we don't have only like before where we had just a and b. We have now a c to worry about, and you might ask,
How do we implement these into these letters, theta theta maths? How do we say 4 over 25 is over x minus 3?
well, so I'm going to teach you a little rule. I'm going to do it to its side over here. So whenever we have a over b and it's all divided over c, it's completely valid to simply write it down as a over b times c. It's completely valid. It's okay. So I'm going to give you a little time to think about what that means. If you don't care and you just want to know the answer, then I'll show it to you right now. So the whole idea behind that little rule is that, say for now, let's take c. So we know that c was 4 over 25, wasn't it? 4 over 25. So what happens is we're going to make that x minus 3 a little smaller, so that way we can fit our 4 over 25, and you see what I mean. So what's going to happen is, using that rule we had before, we will put in our 4 here, and then we put our 25 here. And you do that the same thing with b. So you make this a little smaller, or just leave some space, and that b, we remember that b was, well, that's always why if we don't remember, we write it down, 16 over 25. So given that it was 16 over 25, we put our 16 here, and then we put our 25 here like so. And our a, well, again, we make this smaller. We just, well, that's the wrong thing to do, isn't it? We make this, we just give it a little slimmer, give it an operation, and we remove that a because we know what a is. Now I forgot what a is, but we've got it written down, 4 over 25. So we just plonk in our 4 here, and then we put in our 25 here, like so. And that is how they would sort of expect you to present your final answer. And it's very neat, because usually they would accept, say, because we had before our a over something, they would allow something like 4 over 25 over x plus 2. However, I think that's just really messy, and it shows that you have zero understanding in maths at all. It just, no, like, it shows that you just don't know how fractions work and you don't know your GCSEs. So the whole idea is that when you put it in this form, they know what you're doing, they know that you understand your fractions, and that all makes sense. So I hope that made sense, and we're going to go on to the next example right now.
Hi, mein Führer.
Sie suchen also an, Berlin zu verlassen.
Mein Führer, wie Sie wissen, sind alle ärztlichen Administrationen und Verbände, die der SS und Himmler unterstellt sind, inzwischen aus Berlin abgezogen.
Himmler ist ein Verräter. Er wird seiner gerechten Strafe nicht entgehen.
Mein Führer, als Reichsarzt SS gibt es für mich keine Aufgaben mehr hier.
Ihr Ansuchen, Berlin zu verlassen, ist ganz und gar unakzeptabel.
Meine Familie. Falls die Russen mich... Ich muss hier weg.
Sie haben nichts Unrechtes getan. Was Sie mit Ihren medizinischen Forschungen erreicht haben, dafür werden Ihnen kommende Generationen dankbar sein. Ich übernehme für alles die volle Verantwortung. Wir sprechen ein andermal darüber.
Wir können den Gruppenführer Fegelein nirgendwo finden. Er ist nicht in der Bunkeranlage.
Was soll das heißen? Sie können Fegelein nicht finden. Dann suchen Sie ihn eben. Ich will Fegelein sehen. Sofort! Wenn er sich ohne Befehl entfernt hat, ist das Fahnenflucht. Verrat! Bringen Sie mir Fegelein! Fegelein!